An object is placed near a diverging lens beyond the primary focal point, shown in this figure. So we'll draw the ray diagram, and as always, I'm going to start with the dotted line down the center of the lens, where everything's going to change direction. The first ray we'll draw is the P ray, which runs parallel until it hits the lens, and then it refracts along a line containing F, the primary focal point, which is over here. But don't make the mistake of reflecting the ray back through F, because through a lens the ray refracts. So it has to pass on the line going away from that F. So you want to draw this line going up like that. Then we'll draw the F ray. Remember, the F ray starts out along a line containing the F prime, not the F. So don't make the mistake of going from the top of the object and drawing it through the F like this. It has to go on a line containing the F prime, which is over here. So this ray, you want to get your ruler lined up from here down to that, and then you want to start the ray going toward that one, so it'll look kind of like this, going toward it. But when it reaches the lens, it refracts, and it refracts parallel to the axis. So from that point forward, you should have a horizontal line. And then the third ray is the midpoint one, so we'll just go straight to the center of the lens and keep it going on the other side. You can see that all three of these rays are diverging away from each other, which means that we're going to have to trace them backward to find the location of the image. So the P ray, which is the purple one, will trace the refracted part backward like that. The F ray, which is the red one, will trace that one backward to about right there. And then the blue one, that one just goes backward on itself. All three of those rays, if everything was drawn perfectly, you should see them cross about right here. So we're going to draw an image arrow, and it's a really tiny image arrow this time, pointing upward. So you can see that the image is virtual because it's on the same side as the object. It is upright, and it is smaller than the object. So we can write down the things that we know. The focal length was given as, because it's a diverging lens, it's a negative focal length, so negative 20 centimeters. The height of the object is 2 centimeters, and the object is placed 30 centimeters from the lens. So to answer part B, the 1 over di equals 1 over f minus 1 over do. So we have 1 over negative 20 minus 1 over 30. Common denominator is 60, so it's minus 3 over 60 minus 2 over 60. Negative 3 minus 2 is negative 5 over 60, which simplifies to negative 1/12. So take the reciprocal of that, di is equal to negative 12 centimeters. That also means that the image is virtual, since it came out negative, so that first one checks. For part C, the magnification, you should know the hang of this by now. Negative di over do, we have negative 12 over 30. That simplifies down to both the top and bottom are divisible by 6, so it simplifies down to a positive 2/5 or a positive 0.4. Either one of those answers is acceptable. The positive means it's upright, and the number is less than 1, which means it is smaller. So both of those parts check out. And then for part D, the image height MHO is 0.4 times the height of the object, which was 2 centimeters. So you get an image height of 0.8 centimeters.